Well, hello everybody. My name is David Sneider. Thank you all for being here. We've got a nice crew here, so if there's questions that you have as we're going through this, feel free to put your hand up. We can keep this conversational. If not, leave some time at the end to get into any thoughts. So today, over the next couple minutes, we're going to cover these three core questions. What does private data mean? Why does it matter? And what is the work that we're doing at Lip Protocol, and how does this affect private data? All right. So for a view on privacy, there's, I think, a generally kind of accepted notion that privacy is around what's mine is mine and nobody else can see it. But if you look at how privacy actually works in the real world, it's less around building walls. It's more around building bridges. The reason that we want privacy is so that we can selectively disclose or give consent to data, to information, potentially to capacity for what we have. So we'll kind of keep this view of privacy in mind around consent and selective disclosure. And so if you're in this room, you probably already get this story. This is a screenshot from the film The Social Dilemma on Netflix, if you've seen that, around what kind of like a caricature of what has happened in the Web 2 world. Maybe not for malicious motivations, but some may claim that society has started to fracture based on people being, like the companies like Facebook, incentivized to keep people's eyeballs on the page. And because that data is owned by Facebook, we end up in this really weird feedback loop where there's more division and strife. And we can look at this through the lens of data and saying that, like, potentially one of the core reasons for that is people don't have their own authority over their own data in terms of building these bridges to the parties that they want to consent that access to. And so, like, this whole world that we're in terms of distributed storage and distributed state and access control, there's a lens by which this has been like fun for the past several years. The motivation for building these systems has been like cool and nerdy and intellectual. But with the rise of AI, I think it should be a real alarm bell for what we're building. And like, there's really no alternative other than the decentralized, resilient, user-owned systems in terms of the treatment of data as it relates to the impending AI revolution. What you see on this slide is from this paper, Situational Awareness, and their prediction is that in 2027, the AI will be able to do the role of the researcher and engineer. Typically, this is referred to as AGI. And then, of course, that's where the speculation starts around the superintelligence and anything else that may come after that. So we have only a couple short years to get the resilient systems as it relates to data together, as it relates to user-owned data, to basically provide an enclave or a kind of a bunker for people. Because there's a real potential that things get pretty crazy, pretty fast in the years ahead. All right. And then this is a screenshot from Vitalik Buterin's post called My Techno Optimism, just kind of continuing this view around where we're going societally. You can see there's this, the Vitalik's view, as you can see, is labeled there on the far right, which is like, there's both scary paths ahead and also really delightful paths ahead, compared to the accelerationist view, which is just like go, go, go without any kind of defensive view in mind. And then kind of the Luddite view around, hey, we need to just stay with what we have. Let's not develop anything. The danger in the past represented by the bear here. Cool. So with that preamble, hopefully you are as convinced as I am that this type of stuff is extremely important work that we're all up to collectively here. I'll tell you a little bit about the work that we're doing at Lip Protocol and how it applies to private data. But as you can see, this is a network that essentially provides signing and encryption as a service. The key material is managed by a distributed network inside of secure hardware. We'll take a look at some of the architecture in a second. And we see this network be used for a wide variety of use cases. everything you see on this list, there's one or more venture-backed products building in these categories that are leveraging lit in some capacity. And functionally, what we've tried to do here is take the vision of Ethereum, which is to have a decentralized system be fully programmable, and rather than apply it to state machines, apply it to the world of key management, which is to say decentralized and programmable signing and encryption. So let's talk a little bit about how it works. This is a simplified diagram of one of the lit nodes. As you can see, there are 3 components. We'll kind of go from the outside in. First things first, there's a sealed hardware environment. This is something called a trusted execution environment. What we have done is written a specific operating system. We call it lit OS for right now just one specific processor, which is AMD SEV SMP. It's an encrypted VM. And the reason that we had to do that is that these kind of secure processors, when they're built for the Web 2 cloud service providers, the Web 2 cloud service providers, of course, are operating on a fundamental assumption that the application owner is entitled to all of the data. Here in Web 3, we have a different perspective, which is the user is in control. If the user wants to let the application owner access their data, then that's a step that the user can decide. And so, yeah, the kind of that initial wrapping component is this sealed hardware environment. So neither the party that physically has the computer or the party that is renting the computer, the operator, is able to see inside of it. It is essentially a black box. Now, inside of that black box, there's 2 core components, as you can see here. One is a key share. We'll talk a little bit about that in a second as part of multi-party computation, threshold secret schemes, as well as a JavaScript execution environment. And so the network consists of multiple of these nodes. And as you can see, there's 2/3 of them that have green check marks, and that is in place to represent the 2/3 threshold required to either sign or encrypt with that distributed key. So each of these nodes contain a different key share, and in order to decrypt or sign something with this distributed key managed across this network, 2/3 of the nodes need to provision an authorization to do so. This is what's called a signing share in the MPC world. And pretty kind of interesting fact about this is as developers write applications, and we'll take a quick look at some of the methods that are available here, but it's written in JavaScript. That JavaScript lives at a specific content ID, a CID on IPFS, and that's how this system can essentially have immutable programs, aka like the equivalent of smart contracts, but now we're talking about decryption and signing, not about state. And when a user says, hey, lit network, wake up and perform some operation from me, use this CID, each of the nodes pull that JavaScript off of that CID. It's not efficient. All of the nodes are running the same computation, but it is distributed and secure. All right. So I'm just going to go through a couple quick examples of how this access control works. Basically, what we're looking at here are these JavaScript rules that are executed by this network. And the flow here is, let's say in this example, Alice makes an NFT, and Alice says, you have to own my NFT in order to decrypt and download a video or a compute job or whatever it might be. So we can see here, Alice would set that up. The user address has to have a balance of greater than 0 of the ERC721 token that is associated with this contract address. And so when Bob buys that token, that NFT, he makes a one-to-many call to all of the lit nodes. Each of those nodes, as we were looking at a second ago, independently validate, does Bob own this NFT? And then each of them sends their authorization down to Bob. Bob collects those client side, and once he's collected enough of them, 2/3, he's able to go ahead and decrypt that content. The system also works with custom contracts. So we've seen a bunch of sophisticated access control-based contracts built out across a variety of chains. This is for EVM chains, Solana, Cosmos, all of the chains. The system can also read any state that is not stored in a blockchain. So if the lit nodes need to contact an API to see, does this person have access, yes or no, they could do that. These things can be programmed together with and or operators. So you could build out some pretty sophisticated access control. And I'll tell you about a couple of the use cases for this access control. So let's do a quick kind of loop here. Fox Corp has launched a product called Verify. It is a content syndication network for media companies. So a publisher writes an article, then they encrypt it client side and upload it to the system that's built. It uses Polygon CDK for blockchain, IPFS for state storage, and Lit for encryption. That's the stack that it uses. And then a user buys a license, which is reflected on their app chain. And then that user says, hey, I bought this license, and does that same one-to-many operation that we talked about a second ago in order to decrypt that content. Their intent here is kind of a media-to-machine interaction marketplace. Like they're envisioning the future consumers of all of this media being AIs and AI companies, which is kind of interesting. Streamer is a data marketplace, more generalized. Silky Sign-On is using Lit encryption to back up user key share material, basically for backup and recovery. Lens Protocol uses this system for token-gated posts, so similar to like a Patreon type of setup in terms of you have to pay something or own something in order to decrypt it. And then we've also seen a number of digital product NFTs leveraging this system. NFT marketplace called Another Block got access to Michael Jackson's, or it was the Jackson 5 first studio recording. That data got encrypted and uploaded to the open web, and they sold 1,000 of these NFTs. You need to buy one of these NFTs in order to decrypt this album and listen to this recording, and all of the stems were in there and stuff like that. So pretty interesting. Just a few weeks ago, we put out a new feature for computing over private data. So what you see in this top row is what we have been talking about, where a user says, I want to decrypt this. The nodes in that threshold way run the logic, and then they send the authorization down to the user who can decrypt that data client side. A new feature that we pushed out is the ability to decrypt data inside of Lit, which is to say inside of the trusted execution environment or the secure hardware, and then run compute on top of it. So some of the early explorations that we've seen with that are things like somebody uploads a driver's license, and then they do some OCR over that driver's license to pull out the birth date, and then run a simple program that says, what's today's date minus their birth date? Are they over 21, true or false? So essentially generating a proof over private data. There's really a whole lot to explore there that we're super excited about. And as you all know, asymmetric cryptography has two fundamental features. One is encryption that we've talked about here. The other functionality associated with Lit protocol is programmable signing. Teams use this for wallet as a service, for chain abstraction, for a bunch of orchestration in terms of cross-chain interaction. As you can see, I've talked about half of the picture here, and there's another half, but if you want to talk about the signature side, feel free to pull me away later on. And yeah, with that, just wanted to share this perspective and then open it up for questions, which is there's a perspective that we take, which is one thing that Satoshi did, of course, other than inventing Bitcoin, is really come up with a new way to think about how to use digital signatures. There's a view by which that's what blockchains are doing. It's a novel application of digital signatures. And so there's a lens that we like to look through, which is like, what we've got here is a digital signature revolution, basically, and a full revolution and update in identity. And it is from the signature and from the key that all of our favorite attributes of blockchains in terms of sovereignty, digital ownership, user power emerge. And so with that, here's where you can find me online. I'm also here physically in this room where you can find me as well. And I would love to take any questions, and thanks for being here.